This question is very recognizable as a point of intersection question. Now we could guess and check here because the answer choices are supposed to be the y coordinate, so we could work backwards and use a strategy, but honestly I think it's probably faster to do the algebra, so I'm going to teach you the algebra, but I'll show you how the guess and check might work at the end. So whenever we have a quadratic is one of our intersection points here, or one of our equations, we're really going to need to rely on substitution to kind of bring these two equations together and find that point of intersection. And luckily they're both written in y equals form, so we can substitute one equation for the other. So we can take that 5x plus 1 and plop it into y in the second equation because that's what y is equal to. It's the same y. Some people just remember this as like set the equations equal to each other, but it doesn't always have to be in y equals format, or at least not both of them. One of the equations needs to be as x equals or y equals, then we can substitute, but there's lots of combinations where that could happen. Here is just the most traditional, so we'll do 5x plus 1 is equal to x squared plus 3x plus 2, and now we have a quadratic equation that we can solve, but remember how to do that. For quadratics, we got to bring everything together and have one side equal to 0. So we're going to minus the 5x, we're going to minus the 1, and that's going to bring 0 over to this side, x squared minus 2x plus 1. Now, I could have brought all this stuff the other way, but I don't want to do that because I really want to have a equals 1 for this x squared term. So if I brought it the other way, then it would become negative, and that's going to mess with my factoring. Factoring is always easier if we have a equals 1. The number in front of the x squared is 1. So now I can just think, okay, what multiplies to 1 and adds to negative 2? Well, that is going to be negative 1 and negative 1. This happens sometimes, and it's the same number, right? And luckily, 1 doesn't have a lot of factors, so we kind of have to force it. So negative 1 times negative 1 is positive 1. Negative 1 plus negative 1 is negative 2. And so what happens is when we solve each of these little factors, we get x being 1 twice. Okay, now that's the trap answer, choice A. It's really kind of nice to see it there because it kind of lures us in, but remember we are being asked for the y coordinate. That's really easy to find. Just take either equation and plug the x coordinate in and it'll pop out. So I would choose the one that does not have a squared. 5 plus 1 is 6, and that is my y coordinate. Now I could have guessed and checked, like I said. I don't think it's that efficient. I think you're going to need to know how to do these algebraically. Sometimes they appear in the grid-in free response questions, so you're going to have to just know the algebra for those cases. But in this case, if you didn't feel confident in the algebra, you could just kind of brute force it by you doing guess and check. You just got to make sure that all of these choices are going in for your y. Okay, so I would start in a lazy order. I would do it in this order. I would do choice A first, then I'd do choice B, then I'd do choice D, and if that doesn't work, I would just pick choice C because I don't want to deal with the fraction. So if I wanted to try choice A, just to show you, I would say that y is 1, so 1 is equal to 5x plus 1. We've got to solve for the x, so you'd subtract 1 over. 0 is equal to 5x, so 0 is equal to x. Then I would take that and plug it in the second equation, and that would be 1 is my y. I'm going to be consistent there. And then 0 squared plus 3 times 0 plus 2. This reduces to 1 is equal to 2. That's not true, obviously. And that is proof that this would not be an answer. And then we would just go down the line and we would do it until finally it would work in choice D because we would get something like, I guess, 6 is equal to 6. And so we would know in that second equation that it was the right point because that's proof that that point we found works in both equations. It's a lot to think about. Guessing and checking is usually much easier when we have lines, but we can do it on a lot of point of intersection questions. So it's always kind of in your back pocket if you're not feeling good about the algebra. So I guess in that way, there really isn't an excuse for getting something like this wrong.